All right. Well, we are 2 minutes past the hour, so I think I'll get started here. Yeah, please. I see. I think Terry said hi on Discord. Please just say hi on Discord, and I'll make this a friendly thing. So if anyone wants to share what they've had going on this week or what they got coming up for the weekend, definitely feel free to do so, and I'll try to kind of periodically check back in on the Discord here. But all right, let me share my screen. Oh, first, let me let Nicola Dipol in. And now let me share my screen. And I'll bump this up. I think that's probably good with this. Really good size. Can everyone see that okay? Anyone want to give me a little, just on the Discord, like, yeah, that looks great, or too big or too small? Okay, all right, good, excellent. Okay, cool. So what I want to talk about today was reloadable services. So this would basically be a service that you have typically constructed by a layer, because that's the way we construct services, that you need to dynamically reload. So sometimes just in the course of your application, maybe on some given schedule, you need to reload it, or maybe just you need to yourself say, well, right now I want to like reload the service. And I think it's something that there were some ways you could do it in the past in ZIO, but it was maybe not perfect. So I'll go over a little bit of that, of kind of what existed in the past and what was good, what was maybe not as good about it. And then in the latest, or maybe second latest, because we had to do one release just to fix an issue with the Scala 3 compiler, which is not great. But in very recent ZIO release, we added some new functionality around this. So I feel like one of the fun things we can do with Zymposium is, we mention things in the release notes, but like not everyone's going to read the release notes, or not everyone immediately upgrades to like the latest version. So I think this is a cool opportunity to kind of share new things that are getting added, so everyone can kind of see it and give feedback on it, and we can kind of keep working on improving it and all that good stuff. And this was something I did some work on, and also I'm sure I'm going to butcher this GitHub handle, but Grissom did some work on as well. That was really great. So shout out there. Yeah, let's dive in here. So I've just got the Zymposium repo open, and let me just give myself back this thing so we can just briefly look. So I've just created a new project here called Reloadable Services for what we're going to do. And right now it just doesn't have anything in it except it's going to say hello world. So it's not that exciting. And then I've just updated our build here. I've added a new project for this. It just depends on ZIO. We don't actually need ZIO streams. We get rid of that if we wanted to. But you'll notice I've added one other dependency here of this ZIO macros project. And we'll come back to that in a little while, kind of why that exists and why you might want to pay attention to that. But we'll set up the problem a little bit first, and then we'll come back to that. But just wanted to flag that here. That's the only thing that's like slightly unusual, and we're not going to use it at first, but then we'll kind of add that in to help with what we want to do. Okay, so the basic problem here is again, we want to have some service that we can dynamically reload. And so to motivate this, let's start by just creating a little service for ourselves. So we'll do our usual, maybe I'll call this just a counter. And so we can imagine it's going to have a way for us to increment the counter, and it's going to have a way for us to get the value of the counter. And so we'll do our usual thing of we'll create a companion object for this. And maybe inside this, we'll create a class that's going to implement this. And so a very straightforward way to do that would be to have a ref. Right, and this is going to extend this counter interface. And then we can just implement these methods in terms of the ref. Very straightforward. Just do a population here. Oops. Let's see. Oh, should call this counter live. Follow the practices. Okay. And then just because I want to have some concept of identity for this, mainly for just debugging purposes here, and I want to have some acquire and release actions. I'm going to add a little bit to this live implementation, just so there is an acquisition and there is a release, because that's one of the things that in real services we're going to have. It's not just like this sits here and has some state, but we've got to do something to acquire it, and we've got to do something to release it. So I'm going to add a couple more methods here. So I'm going to do a acquire method. That's just going to do some kind of initialization. And I'm going to add some kind of release method. It's going to do some kind of finalization. And maybe to kind of just have something to do here, I'm going to have another, sorry, I'm just going to let someone else in. I'm going to have another ref that I'm just going to use to kind of hold like a identifier for this counter live thing. And it probably doesn't have to be a ref. We could have another version of this where we just create in beforehand and we pass it in. But I kind of want to illustrate this pattern of kind of having the acquisition and release speed methods on the service, because it can kind of be like a nice pattern that you can use. So here we can imagine that the acquire, maybe we're going to generate a random integer. So that'll kind of be the like ID, not the UUID, but theoretically the ID of this thing. And so we're going to get that. We're going to set it to this. We don't actually need to worry about setting the ref to 0, because we'll just initialize it with 0. And then for our purposes here, I'm also just going to add a debug statement. So we see this. And so we're just going to see kind of the ID of the counter that we acquired, just so we can kind of track when we're acquiring and releasing things and which one is which. And then I'll do the same thing with the release here. So here I've got the ID, and then I can just get it, and I can release it. I don't even need to worry. I'm not going to do anything with it. I'm just going to kind of debug that right now. So, you know, this is not really real finalization logic, but it will show us when the finalization is occurring, so we can kind of keep track of what's going on. So we've got our service defined here. And then once we have that, next pattern is we can do our layer. So this is going to be a Z layer that doesn't require anything. It can't fail. And it's going to return an implementation of the counter service. And so we could use basic pattern is right. We always use Z layer, and then we use a for comprehension inside there. And that'll let us make whatever we need to make. So here I've got an ID I need to make. I've got a ref I need to make. And again, if I wanted to, I could have just generated this random integer up here and passed it in. And probably in a more production type case, that's what I'd want to do. But again, I kind of want to illustrate this, this pattern of kind of making the acquire and release methods on here and kind of how you can do that. I think that can be a useful pattern in some cases. So we're going to create the ID, we're going to create the ref, and then we could just say something like, maybe we'll just call this service is equal to counter live, the ID and the ref. And then now that we have this, we can do service.acquire. And then to deal with this finalizer, I can use this ZIO.addFinalizer operator. So I'm just going to add a finalizer here that's going to release this service. And if I've got that, then I'm going to yield back the service here. And the only change I'm going to need to make is this add finalizer is going to add a scope to the environment. And so to eliminate that, I'll just change from ZLayer to ZLayer.scoped. basically whenever we construct a layer, it's either just straight Z layer, or if we have resources we need to finalize, Z layer .scope. So I'm gonna that, that's all compiling. Format it so it looks prettier. And now I've got my live implementation. And then if I'm kind of following our usual pattern, I could just go from here, or potentially if I'm going to use this interface, the service in the kind of main core of my application, where like my main logic is, then I might also want to implement accessors for it. And here, I think basically my application is going to be nothing other than kind of playing with some examples of that. So I think that'll be a little bit nice to do. So I would do something like I would do val increment. And this is going to be ZIO that's going to depend on the counter service. And this one's going to turn unit. And this is entirely right, except that sometimes the Copilot messes up ZIO1 versus ZIO2. I'm not sure, I guess just based on kind of its when it, its knowledge ended. So this is wrong. This needs to be serviced with ZIO, but this actually isn't bad to just kind of at least help us take out some of the boilerplate here. And then we'll just make this a service with ZIO. Okay. And so that's maybe just a little bit of just refresher on kind of service pattern. And so let's now make a little bit of like an app that uses that. And so now I could do something like I could say, maybe I want to increment my counter 3 times. 3 times. How dare you not predict what exactly I'll do. And then I'll get it. And then I'll just print it out. And I'll build unit here. And so let's see. Okay, I guess I'm having my usual problem of VS Code not actually showing me types, which is lovely, but not unexpected. But if we type this, this would be a ZIO that requires a counter service. This can actually fail an IO exception because of the print line. So we could just or die that if we wanted to, and just returns unit. Did I just spell that, or maybe let me just get rid of that. Okay. And so then if I try to just run this, I'm going to get my nice layer error message that says, hey, you've got to actually provide one of these counter things. And so I just do provide. Sometimes I like to just kind of create separate lines for each of these just so as to add more services. It's easy to add a line for each of them. So we do that here. So I'm going to provide a counter.live. Now this is ready to run. And I can run this. I'm just going to cut this here so we can see the result. And so that's kind of what we expected to see, right? We created this counter. This had this particular identity. We incremented it 3 times. And so when we get the value, we get 3, which is what we expect. And then we see the service gets automatically finalized when we're done with it. So that's kind of all as expected, so to speak, but doesn't actually build in the reloadable aspect. So we'll do that in 1 sec. I'm just going to check in on the Discord here. Yeah, so one has a question. There's, there are definitely things in ZIO that we try to have like an opinion on things, but like it's not like a dictatorial thing, right? There's no ZIO police that's kind of gonna come for your code if you do things a different way. So there are some things where there are like differences of opinion. So some people kind of debate like, should this be a case class or not? Because you could say like, hey, a case class should kind of just be data versus an interface. But I recommend using the case class here. Basically, the reasons for this is like, hey, this is just this. It's just a product type, right? It's just a product of these 2 things. It's just in this case 2 refs. And I also really like it because I always try to think about simplifying the like subset of Scala that you actually use. And so, yeah, one of the problems in Scala is you have all these different things. You have like a class and a case class and an abstract class and And now you have enums and all these different things. And I kind of like to give people like simple guidelines. And so basically what I like to say to people is everything is either a case class or a trait. There is literally like nothing else in the world. Like, unless you like know exactly what you're doing and you have some very specific reason for doing things, which probably, you know, if you do, then you should have the confidence to do. There's no reason you need anything else, right? Every interface is a trait. Every data, depending on whether it's a sum or product type, is either a case class or a sealed trait. There's never a need to do anything else. So that's kind of my recommendation. And that's kind of why, like we say, make everything a case class. But you know, definitely different people have different like opinions about things. And again, there's no like ZIO police that's gonna like come to your house or your place of work if you do something different. You can, I mean, a couple of different stylistic things you can do is some people like to make this private, right? You kind of view like, hey, this case class itself is like an implementation detail. I'm actually kind of a fan of that myself. Not everyone does that. I like doing that. You can make this just a class if you want to. Then obviously you're going to need like, this can't just be counter live, it has to be like new counter live. But you know, it's far from the end of the world. The other thing you can do if you want to is not define a class for this at all, but basically do it in line. So like another way you could write this is you could do something like, this is going to be a little harder the way I've written it here, but let me just show you. So another way you could write this whole thing is you could basically do something like you make these IDs, but then instead of doing any of this here, I just yield new counter. And then I just implement this interface in line right here. And then if I wanted to, maybe this doesn't even need to be a ref, right? This could just be random.nextInt. And then I could just do that and that. And if I compile this and make sure I have any sort of mistakes, that's another like equivalent way to do that. And so this in a way is, it's maybe a little bit less like object oriented, you would say, right? There's no like separate class like we defined before. And I guess could be a benefit or a detractor depending on kind of your attitude. And sometimes I actually like this because it kind of really emphasizes that, hey, there's this interface. There's nothing other than the interface, and this is just an implementation interface, and there's no way you can even interact with this thing other than through the interface. But I think other people find this kind of more straightforward in terms of like, there is an actual class that implements this thing, and you can give it dependencies and you can do stuff with it. So that kind of gives you maybe a couple of different like views of the flavor of that. And yeah, I think probably what I did here is like, if I had to say like one way to like do things, it would be like the one that is like most promoted in the documentation, but hopefully you can see, like even I said here, I have maybe like, I might do things slightly differently sometimes in my own code, and you could do any of these things. So I think all of these are like totally fine and semantically equivalent. But yeah, so I guess that's a little soapbox. I'll kind of probably go back to the original way I had it here, but hopefully that's helpful for people. And definitely feel free to jump in on the Discord if you want to talk about that anymore. Okay, so we're back to, okay, we've got this thing, that this is working. Hopefully in a real application, we have more complex business logic that is using our service than just incrementing something 3 times to gain the value. But we've kind of got a service, it's being acquired, it's being finalized. Okay, that's all great. But now let's imagine that we want to introduce this concept of kind of reloading. So let's imagine we do this whole thing twice. And what we'd like to do is insert some kind of reload here. And so the idea would be that this, in our perfect world, this should be 3. and this should be 3, which is obviously not going to be the case today. If we run this right now, right, this is going to be 3 and this is going to be 6 because it's the same counter. And likewise here, we should basically at this point, we should release first counter and acquire the second counter. And then at the very end, we should release the second counter. Technically, it won't occur here. It'll occur down here when the layer gets finalized, but that's kind of what we would want. And similarly, we kind of would want basically, as far as we can see, we like acquire the first counter, which we're clearly not doing here, right? Right now, we're acquiring 1 at the very beginning, and then we are releasing 1 at the very end. So we don't have the reloadable functionality implemented right now. So in kind of before this latest set of changes, probably the most typical way you would do that is there's actually a data type in ZIO2 called reloadable. Reloadable. Let me see if I can click through to this. Is this? Yep. So this reloadable thing, this is just a thing that exists in the ZIO package and ZIO core. And as it says, it's an implementation of a service that can be dynamically reloaded. And so it internally uses this other thing called a scoped ref. And a scoped ref is basically a ref. So it's a thing that like contains something inside it. In this case, it will contain a service. But the idea is the thing inside the scoped ref can itself be a resource. So it's kind of called a scoped ref because the thing itself inside can use a scope. And you can set a new value for it. And when you do, it'll release the old resource and acquire the new resource. So this is kind of a building block for this idea of, okay, you can imagine we've got one of these scoped refs, we have one of these services inside it. When we want to quote unquote reload it, what we do is we set the new service, and then this will automatically take care of releasing the old one. And the next time we get a value from the scope ref, it'll give us the new value. So the scope ref is kind of the building block here. And then this reloadable thing is a little bit of a higher level interface that we use to work on top of that. And so it basically gives us a way of getting it. And then it gives us this way of asynchronously reloading it. And so the way that we can use this, if we want to, is let me maybe here. I could say val reloadable is equal to live dot with its reloadable manual. Let me make sure that's actually the name. Yes, and I should just remove this that I only created so we can click through to it. Okay, great. So this reloadable manual thing, if I, let's see, can I click through to that? Maybe not. Can I pull up Z layer? Let's see. Maybe. It's lower than it should be. Okay. So if I go down this reloadable manual. So what you see is this thing takes a layer that's basically, you start out, oh, I can't edit this. You start out with a Z layer REA, and you get out a Z layer RE reloadable of A. So if I go back to our example here, and I type this would be a Z layer, any, nothing, reloadable of a counter. Let's just make sure that compiles. And so this reloadable thing, just going back to that interface to remind us of it now that we've kind of actually got one of these, has a way for us to get this thing and has a way for us to request that it be reloaded, that we use the same layer that we did to acquire initially to acquire a new one. so let's try to use this thing. So to do that, I'm going to change this to be not counter.live, but counter.reloadable. Now you'll notice here, I've got a little bit of a problem, right? I've kind of broken my original code. And I think I'm actually gonna, maybe I'll call this app one, because we're gonna have to kind of do a new app here. And the reason I've broken this code is that this reloadable thing, you can see it's like actually kind of, it's a separate data type, right? The live layer just returned the counter, but this reloadable thing returns a reloadable of a counter, which is, I mean, it has a counter inside it, but it is not a counter. And so this thing here, it needs a counter because all these methods expect to actually work with counters and not with reloadable counters. So that kind of creates like a little bit of a problem here, because essentially, in a way, we like the fact that it's reloadable to be like a implementation detail, right? We'd like to have a counter and a reloadable counter, and like a reloadable counter just is a counter. And so we can use a reloadable counter anywhere that we need a counter. But this is kind of this separate data type. And so what this is going to require us to do is to kind of rewrite our code in one way or another. So maybe I'll show us like a couple of ways we can do that here. So one way is I could just, I could grab this reloadable thing. So I could say reloadable, probably the way I want to do it too, is going to be, let's say ZIO.service, reloadable counter. And if I wanted, I could make some operator for that, but I'm not sure it makes sense. So now we've got this reloadable thing. And so then I could say, well, counter in reloadable.get. So this is now my first counter. And then instead of this capital counter.increment, I do the lowercase counter.increment. And then I can print that out. And now that I've got a handle on this reloadable thing, I can do reloadable.reload. And then, and just we go back to interface. Let's do it's actually not reload, it's reload fork. So I'm going to do reload fork here. And then normally the reloading would typically be occurring in a separate asynchronous process from like the main application, which is kind of why it has this fork semantic. But here, just because I'm kind of doing this like demo and I want the demo to like have its expected semantics, I'll do like a little sleep here just to make sure this reloading actually finishes before we go on. And then I could get the counter service again. And so now if I'm finished with the reload, this should now give me the latest counter service. And then I can update all those things there. And then let me just let me comment this out for a sec, just so I get back to the compilation for a second. And so now if I type this, this is now going to be a ZIO that uses a reloadable counter. And so now I could go back and here I could do app2 dot provide counter.reloadable. And so now let's try and run this. Let's see what we see. Okay. And so positive thing here is this is now kind of the result that we want, right? We acquire this one counter at the beginning of our program. We're working with that one counter consistently. We increment it 3 times, we get its value, we get 3, fantastic. Then we call reload. First, it makes sure to release the old counter. Then it acquires a new counter for us. And then we work with that counter. That's a new counter, so it starts at 0. It's got a new ID. We increment 3 times. We get its value. Its value is 3. And then at the end of our application, we release it. So I think good thing here is that this does what we wanted it to do, but we can see this was a little bit, maybe invasive is too negative a word, but like we had to change our program logic to accomplish this. And I mean, not in like some terrible way, but in a way where it's not just a drop-in replacement of, we actually had to change the implementation of the app. We couldn't just change the implementation of the layer. We can just quickly check in on the Discord, see if anyone has any questions. He has the police plugin. Maybe that, I mean, he has all those tooltips, many of which are, I mean, they're all helpful and they're kind of trying to help you keep out of trouble. But that would be a fun, cheeky way to play with that. Okay, so anyway, so before we kind of go on to like the better solution, let's think for a minute about like, why did this solution exist? And the basic reason is it's hard for us just programmatically, at least with normal Scala code, to kind of create a reloadable version of an arbitrary service. Because let's imagine that you give us one of these counter things and we want to give back another counter thing that is the reloadable counter, but truly satisfies this counter interface. So if we talk conceptually about how we do that, it's actually pretty straightforward, I think, conceptually how we would do it. We just basically, if we're given, I mean, let's maybe try to make a little just function for ourselves to play with this. So what if we said, like, so like, what if I wanted to say like def reloadable? And so this would be, let's say, environment error service. And so let's say I have a layer that's a Z layer environment error service. And we said that we basically want to return back some, basically the same thing, still got to return the same service. There's a little bit of like a question here of like, let me just get rid of this so a little more space. A little bit of question of like how we're going to get the reference to the thing that reloads it. But if I have this, let's just think about like how we would implement it. So conceptually, I could say, well, let's create one of these scoped ref things. Then I could say, build the layer and put it inside the scope ref. And then I could say, create a new implementation of service that implements all the methods of service and does this by getting the value inside the scoped ref and calling the corresponding method on it. Does that make sense to everyone? Just like, does that like logic of like, if we could implement that, do you see how that would like solve our problem? Yeah, I mean, one says a kind of proxy. Yeah, exactly. That's basically exactly what we want. We want to create a proxy for this service that, just if we kind of sketch this out, if we imagine that this was like a trait service and it had a method foo on it that returned whatever, yeah, UIO unit, then we want, if that's kind of our interface, then we want to create something that is like new service, and def foo is actually something like scoped ref.get.flatMapFoo, right? That's kind of what we conceptually want to do. So conceptually doesn't seem that hard, but if you just want to do it with kind of ordinary Scala code, it's actually impossible to do this, because if you look at this service is just this type. We have like no information on what this service is or what methods it has on it. It could be a counter, it could be a database service, it could be something else, it could have one method, it could have 10 methods. We don't know what arguments they take, we don't know what they're supposed to return. So even though like conceptually we can like describe this and say, well, whatever method it does have, delegate them, we can't implement that in normal Scala code. And so that's where this more recent work came in. And this gentleman whose GitHub handle I'm probably continuing to butcher, Grissom, did some really great work on building a macro to do that. Which this is the kind of the thing, a little bit like what we did with like automatic layer construction of there are some things that you can't do with ordinary Scala code, but that you can do with macros. And sometimes they can be very nice for user experience. And so that's where this, if we go back to this build file for a sec, that's where this ZIO macros library comes in. So this is one that has existed in a long time in various forms. Like at one time, way back in like ancient history in 2019, it had kind of the predecessor to like almost like this was before layers even existed. It had kind of predecessor for layers. If it had some macro to kind of automatically construct like services that implemented multiple of their services. Then for a while, it kind of didn't do anything. But it's kind of coming back to life a little bit as the home for some of this like basically macro powered functionality to support a better developer experience. This is something that actually can't be in ZIO itself because there are some implementation restrictions with macros that basically you can't define a macro in the same compilation unit as the stuff that you're using. And so this macro uses scoped ref and uses some of that stuff we saw. So it uses ZIO, so it can't be in ZIO itself. So it's in the ZIO macros project. And I imagine over time, you may see more other functionality like this that is kind of trying to help you have just a nicer experience that lives in here. So I think it's worth kind of keeping an eye on. So all I've done so far is I've added this ZIO macros dependency. And then let's look at how I can use this to implement this in a less invasive way. So I'm gonna get rid of this because I think we saw like I can't actually do this. Which is why it's nice that we've got something we can rely on here. And so let's instead of doing this, let me just maybe I'm gonna comment out my this. So I'm compiling again. And so let's change this reloadable. So instead of this old reloadable manual thing, let's just, I really cannot spell that correctly. Okay, so you see we're not getting this reloadable, and that's because I don't have macros imported yet. So let me bring that in. And then we're on Scala 3. So we're going to get a little bit of another somewhat annoying thing on, this is not an issue on Scala 2, but if you are on Scala 3, there's this kind of annoying thing they have where this has to use macros that are unfortunately still experimental for reasons. Hopefully that will get fixed at some point, but basically we can't use this unless we mark this scope as experimental. So I'm going to do that here. I'm going to do at Scala.annotation, experimental. Again, you don't need this if you're on Scala 2, which probably the vast majority of you are. Experimental. Okay. And then that kind of has to like propagate through. So I think that means that this whole thing also needs to be Scala.annotation. All right. That is all happy here. So now, let's look at the type of this. The type of this is sure. Oh. Okay, so let's look at this type for a sec and kind of notice what's really cool about this and also some other things that we're going to need to like use this. So the first thing to note is the type here is what we want. It's just a counter. It's not a reloadable of a counter, it's just a counter. And so we can use this anywhere our code expects a counter. So this is basically this macro internally is doing this wrapping for us. Let's see, I wonder if I can actually, okay, doesn't look like I can click through here to show you that because of VS Code, lovely. But it's internally doing this proxying here. And so it's gonna let us just make this a drop-in replacement in our application. You'll also notice it's done something to the error and the environment types. So the first thing it's done is it's added this service reloader as a dependency for this layer. And you can think of the service reloader as almost being a service registry. So every time we use reloadable on a service, it's going to add this service essentially to this registry. And this registry is what we're going to be able to use to reload one of these services. Because if all we have is the counter is itself doesn't have any reloading as part of its functionality. So we need to have some way to get a handle on the ability to do this reloading. And the service reloader is that thing. It kind of keeps track of all of that state for us and handles that for us. And then the second thing you'll notice is it's introduced this error type, the service reloader.error, which is basically going to capture the different types of errors that can occur with, and yeah, this is the wrong error. But basically, this can either be an error where the original service acquisition failed, or it's going to be potentially an error if, like, let's say we try to reload something that doesn't exist. So that's kind of the idea behind the service reloader error here. So, okay, so now we've got this reloadable version. And so now let's look at how we can kind of clean this up. So now I can go back to my app one. And let's try compiling this. And so now I'm getting this message, hey, you need to provide a service reloader. And that's very easy. I can just do service reloader.live. And so now I can blow away this whole app2 thing, right? I don't need any of that. So let's kind of clean some of this up. Okay, I think we're good with everything else. So now, so far, let's just try running this. Let's see what we get. So far, we still don't have our expected behavior, which makes sense because we haven't actually asked to reload the counter at any point. So let's see how we do that. All we need to do is here, we just call in, we're just going to call service reloader.reload. And just like layers kind of build instances of each type, and the Z environment contains an implementation for different types. The service reloader, you can think of itself having internally kind of a map from these different services to these reloadable implementations of them. And so when we ask it to reload something, we tell it which service we want to reload. So here we want to reload the counter service. And now let's see what happens here. Oops. And, and let me just get rid of this type because we have introduced this possibility that we're trying to reload something that doesn't exist here. But right now I'm just gonna put that. Okay. And so let's look at what we got here now. So we got exactly what we wanted with a reloadable service here, right? You see, we created one instance, we worked with it, we incremented 3 times, we got its value, it was 3. Then we called reload, and we released that first service. We released it before we acquired a new service. We acquired a new version of this service, and we incremented it 3 times, and we got 3 again because we started from 0. And at the end of our application, we released this. And the only change we had to make to our code versus our very original code was we had to add this service reloader.reload to say we actually want to reload it. And of course, this wouldn't necessarily even have to be in the same part of our application. If maybe we imagine that this is going to like wait for 10 seconds here, maybe we can show this. So like, what if we did, maybe I'll make this ZIO.sleep for 10 seconds. And so then what if I said, well, I want to take that thing and then I want to run it in parallel with service reloader.reload, the counter service. And let's delay that for 5 seconds. Make sure I haven't done anything silly here. Okay. And let's try running this. We'll have to be slightly more patient. Yeah, so we say we reloaded after 5 seconds. And then we proceed on with the rest of our application. And so now our original code can kind of be agnostic to the fact of whether this is a actual counter or a reloadable counter. Right, if I just switch this and maybe I go back to counter.live, now I'm going to get the old result, right? I'm going to be working with oh, so this is a great example here. So here, I'm getting one of those service reloader errors, right? Because I'm trying to reload a service that was never registered, which doesn't really make sense here. But you can see how now, like if I want to get rid of this whole thing and I want to kind of go back to my original application, I can just do this. And I've got the version that doesn't reload. A little bit of delay. Maybe I should make that shorter. And right here, I get 3 and 6, which is what I expect if I'm not reloading. And if I want to reload, all I do is I just swap in counter.live with counter.reloadable. I add the service reloader as a dependency. And then if I want to actually reload it, I need to add the reloading logic somewhere. It can either be in a separate process like here, or it could be in the original process if I want to kind of update my code there like we did before. And so I think this, again, it's not like a revolutionary feature and you know, it's not going to change everything, but I think for this like particular problem, it's a significantly nicer developer experience than we had before with the kind of reload manual that's powered by these macros here. It's available on Scala 2 and Scala 3. It has the same interface. So yeah, that's kind of it. It's a specific problem, but if you have the problem, it's a nice solution for it, I think. Okay, I'm gonna open it up for a minute for questions here. And then if anyone has anything else, we can chat about anything else, or otherwise we can call it a weekend. I see lots of people typing, so I'm getting on it. Yeah, so if you want to have multiple instances of the same service, it's kind of the same problem. It's the same problem slash solution as you have if you have multiple instances of the same service in general. So I think probably the most straightforward one I recommend is just creating a new nominal type for it. So for example, if you have, like, maybe we have, I don't know what kind of things we want to count, but I don't know if we want to have like a cookie counter and a fruit counter. Kind of the most straightforward thing is to have something like a final case class cookie counter, and basically just have the counter inside of it. And then that's kind of a more strongly typed version. And then if you want a more dynamic version, the other thing you can do is you have something like a map from string to counter in the environment. And so you can imagine this would be like a map from cookie to the counter for cookie, and the fruit, the counter to fruit. And there's actually some built-in support in ZIO for this. There's an operator called service at that will kind of look up the implementation of a service that corresponds to a specified key. So those would be kind of the solutions you would use for if you wanted multiple kind of implementation of the same service. But in a way, the most straightforward is kind of don't create those separate nominal types for them. And then, so there's a question of what if you register multiple services to be reloaded, but you specify the wrong service to reload in the wrong context? So there's not really a way to do that, because imagine here, I guess we'll have to create some other service, but imagine we have trait foo service, and it has like foo, object foo service. See how much help I can get here. Yeah, good enough. So if I have this foo service here, and then I have like the reloadable, I can't do that correctly, is live.reloadable. Let's just make sure this compiles. Oh, I'll just rebuy this. Okay. So if I've got this thing here, and then let's add foo service.reloadable here. And then let's say I change this to reload foo, foo service. And let's imagine I am doing something else where I'm using the foo service. So like I'm doing, like I said, let me implement a little accessor for it. So let's say here I do like service.foo, and then I do all this stuff. I just need parentheses around this whole thing. Okay, so if I have something like this, it's not really possible to tell at the compiler level whether foo service or counter service is the one that you want to reload. If you're trying to reload a service that just doesn't exist at all, then we can throw an error for that because that doesn't make sense. But here, like imagine here, you have kind of this concurrent process that's reloading one service relative to your main application. So we kind of know internally that like what we want to do is that we want to reload the counter service versus the foo service, but there's really not a way statically to know that. So you do have to kind of actually ask to reload the right service, but I think that's pretty reasonable, right? I mean, it's like if you're updating some like map, you have to like update actually the right key if you kind of say the wrong thing, then the wrong thing is going to happen. But you need to have kind of the flexibility to upload whichever service you want, or to reload, I should say. Okay, so I think we're just about at time here. I see a couple of people typing, so maybe I'll wait one more minute, and we'll do one more round. Yeah. Okay, so yeah, I see Peter and Juan, so I'll give them a minute here. So Peter asks, is there a release mechanism? Well, so the release mechanism is really built into the reload. The reload is what triggers the release of the prior service and the acquisition of the new service. It doesn't really make sense to release without acquiring a new service, because then anyone who's a client of the new service is just going to kind of blow up, because there's like nothing inside that scope draft. Like, kind of the guarantee has to be that there's going to be something inside, or if it's reloading, you have to wait a minute while it reloads. But we can't let that scope draft just have nothing inside it. So again, maybe if I make this the counter again, and oops, and I run this, you can see it's at that 5-second mark. It's when this reload is run that it triggers the release of the first service. And then once the first service is released, it triggers the acquisition of the new service. So, and then Juan is right that this is global. Generally, I would say you don't want to have services that are specific to a fiber. Services internally may want to use a fiber ref for fiber specific functionality, but I don't really see fiber specific services. So yeah, I would typically think about that as kind of what goes inside your service versus having kind of separate services for each fiber. The environment and kind of fiber refs are kind of two different ways to maintain state. Okay, well, cool. Well, again, I really hope this was helpful. It's always fun to show off new ZIO features, and hopefully this helps you in your actual work. And yeah, again, shout out to Grissom, who did some of the work on that. And yeah, look forward to sharing more stuff with everyone here, and being able to give recognition to more awesome stuff. I think next week, we're actually going to have Eagle, the guy behind ZIO IntelliJ plugin, coming to talk to us about a new project that he's been working on called ZIO Clippy, which is kind of like Clippy in Rust, but kind of gives you nicer error messages. So, or yeah, I think nicer is fair to say. So you may have noticed here that when I did something that like wasn't quite right with these, like if I type this, it's like ZIO any nothing unit, oops, unit spelled correctly. And I compile this. Well, before even that, let's see, what's this? Okay, that's not quite showing what I wanted to show. Okay, well, I won't show it here, but basically, when you don't get this nice message that kind of Kit puts together, you just can kind of get something that is not the most readable. Let me maybe do val example ZIO any nothing. Oh, I think it's because it's in here. Yeah, let me move this up. Do like oh, here, where's it? Yeah, so let's say that I make this any instead of counter, right? It's supposed to be counter. So I compile this. Oh, I'm still not able to do. Okay, here we go. Let's do this. That should. Okay, so I get this whole thing, and I mean, here it's actually not that bad, but I think probably a bunch of you before have been faced with like these like giant error messages. And it's a little hard to tell what's like wrong because even here, like they've tried to improve a little bit with Scala 3, but like this counter live thing is in red, but this actually isn't a problem at all because like the counter live is a subtype of counter. So this is totally fine. This in a way should be green versus red. The real problem here is this like scope versus any. And even if we have like a bunch of things, like the whole thing's going to be red versus like just the particular thing you're missing. If you can imagine like, well, you needed 20 services and you only provided 19 of them, you're gonna have to like copy that to something else to like diff it to help find that thing. So this Clippy thing kind of really zeroes in on that for you. So we'll be talking about that next week. And then the following week, Peter, who I think is here and that's actually asking one of the questions, is going to be joining us to talk about his work on ZIO logging. So lots of good stuff, and I think we're gonna have more good stuff to share in the future. But yeah, that's what I got for you today. Have a great weekend, everyone.